Hello guys, this is Prime Concept. In this video, I want to establish a very important concept which is actually the foundation for mechanics in physics. So I want you to stick with me in this video till the end, and you'll be learning very important foundational concepts that would help you build your knowledge of physics. Now in this video, I want to look at the study on units, measurements and dimensions. So these are the foundation for physics, meaning that you cannot discuss the subject of physics without considering units of quantities, and as such it is very important for us to understand the concept of units, how units are actually useful to us in measurement, and then dimensional analysis. So in this video you'll be learning what units are, you'll be learning the origin of units, you'll be learning how to carry out measurements, you'll be learning conversions from one unit to another, you'll be learning the different prefixes that are used in physics, which is very important. And in the next video we'll get on to the introduction of dimension. So thanks for always following my channel. You are yet to subscribe, please do well to subscribe to this channel, share the video with your friends, tell them Prime Concept is unraveling the concepts in physics and sciences. Thank you. Now let's go straight to the point. In physics, we talk about physical quantities. Of course, I expect that at this point we all know what physics is. So physics generally talks about physical quantities. All the quantities you describe in physics, they are all referred to as physical quantities, right? So what are physical quantities? Physical quantities are quantities that can be measured and assigned a unit of measurement. So anything you talk about in physics that you can measure is actually a physical quantity. Now when I was teaching this to my students physically, I asked them to give me examples of those things they think they can measure in physics. And somebody said water is an example. Now let me quickly help you to understand this. Water is not actually a physical quantity. Now the physical quantity are the parameters that you can measure for water, right? So if you have water, you want to actually describe some certain properties of water or parameters for water. For example, you want to know the weight of water. So it means you can measure the weight of water. So it means that weight is a physical quantity because it can be measured. Another example would be you want to determine the volume of water. So it means that volume, which you can measure, is a physical quantity, right? Yes. Another thing is you want to check the temperature of water. Temperature that can be measured is a physical quantity. So in summary, it means that physical quantities in physics are quantities that can be what? Measured. And to those quantities, you can assign a unit of what? Measurement. So these are what we refer to as physical quantities. So we are going to split the physical quantities we know based on their measurement. We're going to split them into two. But for now, let's proceed. Since we have three terms as our heading, so we want to look at what these terms would actually mean, and then we can dive into the major thing for today. So let's start with measurement. What is measurement? Measurement is actually a comparison between a physical quantity, an unknown physical quantity, and a known or fixed standard. That is measurement. Let me quickly write it. Measurement is a comparison. Between an unknown physical quantity and a known fixed standard. So that is measurement. So measurement is actually a comparison. Now, for example, let me still bring the concept of measurement to our doorstep. Now, for our local markets in Nigeria, I believe it's applicable to so many other countries, but for our local markets in Nigeria, we buy rice. We buy rice, and the standard for measuring rice in my location is a pint. They call it 1 painter of rice. So that is just this custard rubber custard container, the container that they use in storing custard. So that is what we use in my location. So they call it 1 painter of rice. So it means that the standard for measuring rice would be what? 1 painter of rice. So if somebody should bring a big bag and load rice into that big bag and say, this is a bag of rice. Somebody that does not understand might say, what do you mean by 1 bag of rice? What you would simply describe to that person, you tell that person, in order for you to describe 1 bag of rice, which is really unknown to that person, because the person is used to a painter, you tell the person, 1 bag of rice contains 20 painters of rice. So it means that you have compared 1 bag of rice to what? 20 painters, right? Or to a painter, which is the standard for measuring rice. So that's comparison between an unknown physical quantity and a known standard is what we call what? Measurement. And that is the basis in physics. So there is no measurement that was invented by God or that was introduced by God. It was man that actually invented the standards for measurement. So the same thing, for example, I may decide that the length of this board might be a standard for me to determine other measurements, right? So I can call the length of this board, I can call it 1 meter. If I call it 1 meter, it becomes 1 meter for me. This becomes my standard of measurement. So if I have a board that is bigger than this, I can, relative to this 1 meter, I can determine if that one is going to be 2 meters or 3 meters or 4 meters, right? Because I already have a fixed standard, which is now this board. So any other thing relative to this, whether it is smaller than this or bigger than this, I can determine the size relative to what? The standard, which I have called what? 1 meter. So that is measurement in physics. So measurement is actually a comparison of an unknown physical quantity and a known fixed standard. So there is a standard for measurement in physics, right? Yes, that is measurement. Now, what is this fixed standard? The fixed standard is actually known as units. A fixed standard is known as units. So we can therefore say that units is the fixed standard upon which measurement is made. So unit is the fixed standard upon which we make what? Measurement. That is unit. So for example, I might decide that my standard for measuring rice is 1 pint. So it means 1 pint is the unit, right? Yes, I can now determine the size of every other thing. Say 1 bag of rice, I can determine how many pints are there. 10 bag of rice, I can determine how many pints. The same thing in physics. If we say 1 kilogram, it means that 1 kilogram becomes the standard for measuring what? Mass. So 10 kilogram actually comes from what? 1 kilogram, right? Yes. So the unit is actually the standard or the fixed standard for measurement in what? Physics. So we have learned what measurement is. We've learned what unit is, right? Now, dimension, we're going to talk about dimension after this, because this will be the last part of what we're going to do. So very quickly, we have mentioned that physical quantities are quantities you can what? Measure. Quantities you can measure and assign to them a unit of what? Measurement. So these are the things you refer to as physical quantities. Now, we can classify units into two, right? Remember, units are the basics for measurement. So units can be classified into two. So let's look at classification of units. So we can classify units into two. Number one is what you call fundamental, or you can say base units. So number one classification of units is fundamental, or you can call it what? Base units. What are fundamental units? We'll quickly explain it, then we mention number two. What are fundamental units? Fundamental units are units that forms the foundation upon which other units are built. That is fundamental. They are units that forms the foundation upon which other units are what? Built. So these are units. These are units that forms the foundation, or you can say basis, upon which other units are built. Upon which other units are built. So these are called base units. So it means these are fixed standards. Every other one emanates from this, right? Yes. So these are base units. Now, when we are studying mechanics, we have three types. But generally, as technology improved, other kind of quantities now came in. So there was need for extension of the fundamental quantities. So I'll be giving this extension. So I'll be giving all the fundamental quantities that we would be dealing with, or that we should know. So fundamental quantities, which we said are base quantities. So let me manage my space. Quantities, they are the quantities we want to look at their symbols. Okay, let's say their symbols, and then their units. Remember, we're considering the fundamental quantities. So what it means is that if you know the fundamental quantities, which is what I'm going to list here, if you know the fundamental quantities, any other thing that is no longer fundamental quantities will become the second classification, which we are going to look at. So it's very important for us to know the fundamentals. Any other thing that does not fall into fundamental has to be the second classification. So what are the fundamental quantities? Number one, talk about mass. Mass. So mass is a fundamental quantity. And what is the symbol for mass? Is denoted with small letter m. Small letter m. Don't use capital letter, because capital letter will be used when we get into dimensional analysis. So the symbol for mass in physics is small letter m. And what is the unit of mass? The unit of mass is kilogram. Is kilogram, right? Yes. Now we want to talk about number two. Number two is length. Length. What is the symbol for length? Small letter L. Small letter L. And what is the unit of length? Meters. Right? Yes. Number three is time. What is the symbol for time? The symbol is small letter t, not capital letter T, small letter t. And what is the unit? Seconds. Number four, we're talking about temperature. Temperature. What is the symbol for temperature? Capital letter T. Some books may use theta, but this is a common symbol, capital letter T. Right? And what is the unit for temperature? It is Kelvin, which is K, Kelvin. Take note of it. Number five is luminous luminous, I should say light, luminous intensity, light intensity. Number 5, which is luminous intensity, the symbol, we usually use capital letter I as the symbol, right? Yes, but because I'll still have another quantity I'll be using I for, so let me just use a subscript here, luminous intensity, but the actual symbol for intensity is capital I. But because I'll still introduce another I, let me just add a subscript to this, the luminous intensity, so we can differentiate them. Now, what is the unit for luminous intensity? It is candela. Candela. The short form is CD. Candela. 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 Now, number 6 is what we call current. Electric current. An electric current has the symbol capital I. So that is electric current, right? We can still use small I, but capital I is common. Now, what is the unit for electric current? The unit is capital A, ampere. Ampere, named after ampere. Number 7, and the last, is amount of a substance. Amount of a substance. Amount of a substance. Amount of a substance has the symbol of small letter n, and the unit is mole, mol. So these are the fundamental quantities you should know. There are 7. So these are the fundamental quantities we should know. Any other thing that is not here would now become the next classification of units, right? So these are fundamental units we should know. So number 2 classification for units is what we know as derived unit. Derived what? Unit. So it means that we have 2 classifications for units, which is what? The fundamental or base unit and the derived unit. Now, what are derived units? From the name, as the name implies, derived units are units that are obtained by combining 2 or more fundamental units in multiplication or division. Derived units are units that are obtained by combining 2 or more fundamental units in multiplication or what? Division. Let me write it. These are units obtained by combining 2 or more base units in multiplication or division. So these are what we know as our derived units, and they are obtained from fundamental. That is the basic thing I want you to understand. Derived units are derived, or they are obtained from fundamental units. So this is very important for you to know. So it means that derived unit, we can say that the list is endless. So unlike fundamental units where we have 7 of them, so which means anything that is not 7 of this is going to fall under what? Derived unit. So an easy way for you to answer questions in exam can ask you which of the following is a derived unit, right? So an easy way for you to answer those kind of questions and to be always correct is to memorize these 7. So once you know these 7, automatically you know derived units, because anything that does not fall here should be here, right? Yes, so we're going to give examples of derived units. So we're going to give examples. Okay, let me leave this part. Let me rub here. This for now. So do well to hit the subscribe button. You are yet to subscribe and you have followed up till this point. Hit the subscribe button, like the video, comment in this video. Now let's look at examples of derived. Examples of derived units. Other examples, there are so many, but let's start with easy ones. Say area. Area. Now you know that area is actually the product of length times breadth. That is area, length times breadth. And we already know that length is actually a fundamental quantity. Now, one of the things I want you to understand is that length, breadth, radius, height, thickness, width, distance, displacement, all of these things I have mentioned, they are all the same as length in terms of units. When you're talking about units, all of these things I've mentioned are the same, right? So it means that length is the same as breadth. Take note of these things I've mentioned. Same as height, same as width, same as thickness, same as radius, same as distance, same as displacement. They are the same as long as we're dealing with measurement, units and measurements. They are all what? The same. So if that is the case, we want to derive the unit of area. We know that the unit of length is what? Is meters. So I have meters times the unit of breadth is also meters. So it means I would have what? Meter times meter is meter square. So it means that the unit of area is what? Meter square. You can see that is derived from the product of two base of fundamental units. So this is a derived unit and the unit is meter square. Now we can also have say volume, for example. Volume is actually going to be what now? Going to be length times breadth times height, right? Yes, and all these things are the same. So this is going to be meter times meter times meter, which is going to be meter cube. That's the unit of volume, which is derived from base units. Say we have number 3. Say we have, for example, velocity. Velocity. We know that velocity is displacement, or you can say distance, since we are not interested in vectors or scalar. So we can say velocity is displacement over time, right? Yes. And what is displacement? Displacement is same thing as length, and the unit of length is meters over time. Time is measured in what? In the unit of seconds. So I have seconds. So it means I can say from our indices, whenever you have something at the denominator and no power is written on it, it means it carries a power, an invisible power of 1. So when you bring it up, that power of 1 becomes -1. So it means the units can be written as meters. When this 1 comes up, become s to power -1. So you say velocity is meter per second. That means per. When you see power of minus negative, it means per. So per second. Another way you can write this is to say it is meter/second, but I would prefer this first way. So velocity is measured in what unit? Meter per second. You can see it is derived. Let's look at another one, number 4. Let's say acceleration. Acceleration is actually velocity over what? Time. That is acceleration. Velocity over time. And we just derived the unit of velocity. And we said velocity is what? Meter per second. And then our time still remains second, right? Yes. So that when you do this, let me rub what we have here. That will have space. So when you solve this second will come up. So you would have that. Remember, the power of s here is 1. When it comes up, it becomes -1, right? So I would have that my acceleration is going to be meter per second, which is already up. And when the second comes up, it becomes per second again, so that you can combine the both of them. This is your meter. Now, -1 is what? -2. Because these are both s. So I'll just say s to power -2. So it means that the unit of acceleration is meter per second square. Meter per second what? Square. Another way you can write that is to just say meter slash second square. So it's same thing, right? So we want to derive some more relations. Say we have force, which is number 5, force. You can say that force is ma, mass times acceleration, right? Yes, and we know that mass is measured in what? Kilogram. And we know that acceleration, we've gotten the unit, which is meter per second square. So it means that the unit of force is going to be what? Kilogram meter per second square, right? Yes. Which, for the sake of simplicity and honoring a great physicist, science decided to name the unit of force after a man, a scientist that did great work under the study of force. They named it after Sir Isaac Newton. So it means that rather than us using kilogram meter per second square, they decided to call it what? Newton, which uses the symbol capital N. So it means that 1 Newton means that one Newton is same thing as 1 kilogram meter per second square. So you would not see us talking about kilogram meter per second square again. What you would always hear is what? 1 Newton, which is same as this. So let me give 2 more examples, then we move on. Now, say we want to talk about number 6. We want to talk about pressure. Pressure. Now we know that pressure is what? Force over area. Pressure is force over area. Have we gotten the unit of force? Yes, let's quickly write it. Force, this is the unit, which is kilogram meter per second square. And my area we got earlier as what? Meter square. So seeing this, I can write this to be kilogram. This is meter up, which is meter. Then when this one goes up, it becomes per meter square. Then I have my per second square. But I won't leave my answer this way. I have to find a way to simplify that answer. So I would have, this is meter raised to power 1. This is meter to power minus 2. So you say 1 minus 2 is going to give you minus 1. So it means that my pressure P is going to be kilogram, then meter to power minus 1, then per second what? Square. Now this is the unit of pressure. Now, the same way as force, they still decided to honor another scientist that did great work under pressure, the study of fluids. Another scientist did great work, which is who? Pascal, Blaise Pascal. So rather than us using this whole unit, which is long, they decided to call this Pascal, PA. They decided to call it Pascal, PA. Now, say you don't want to call it Pascal, and we already know the concept of Newton. Remember, pressure P is force over area. So, and we already agreed that force should be called what? Newton, and area is what? Meter square. So it means that we can say that the unit for our pressure is what? Newton. When this one comes up, you say per meter square. So it means that the unit of pressure, you can call it kilogram per meter per second square, or you can call it Pascal, or you can call it Newton per meter square. So this is what you would commonly see. You would commonly see this or this. Take note of that. Pascal or Newton per meter square. So one more, which is number 7. One more, so that we can have 7 for fundamental and derived. So number 7, I'm going to give you velocity gradient. Velocity gradient. Now, what is velocity gradient? Whenever you hear gradient, a quantity gradient is actually that quantity over length or distance. So when you hear velocity gradient, it means velocity over length. When you hear temperature gradient, temperature over length. So anytime you hear a quantity gradient, it means that quantity over length. So velocity gradient is velocity over what? Length. Now, what is the unit of velocity? We have derived it, which is what? Meter per second. And what is the unit of length? The unit of length is what? Meters. So that you can quickly see that this can fizzle this. And our answer becomes what? Per second. Per second. So it means that the unit of velocity gradient is what? Per second. So I believe it is clear. Now, this is what exam would ask you, because our aim is preparing you for every kind of exam, which would include WAEC, JAMB, NECO, IGCSE, NEET exam, G exam, JUPEB exam, first year 100 level exam, second year exams. That is our aim, preparing you for all of these exams so that you'll be amply ready. Now, this is what exam will ask you. One of the following, let me write it. One of the following has same unit as velocity gradient. Option A, you would see frequency. Option B, you would see period. Option C, you would see velocity. Option D, you would see, let's say, displacement. So this is the kind of thing you'd see. One of the following has same unit as velocity gradient. So which of them do you think is correct? Thank you, you are very correct. The correct answer is what? Frequency. Because we know that frequency, the unit of frequency is what? Hertz or per second. So it means that frequency has the same unit as velocity gradient, which is what? Per second. So these are the kind of questions you will be seeing under exam condition. So we have talked about the two classifications of units. Now want to look at the next point, which is very important to us, and then we begin to tidy up the video. So we want to look at different systems of measurement. Now remember, we've classified units into two, right? Now we have different systems of measurement, which some of you are familiar with. You've heard me say kilogram. Somebody may ask, why did you say kilogram rather than grams, right? Yes, that is why we want to look at the different systems of measurement. We have three major systems of measurement. There are three systems of measurement. When we say systems of measurement, these are systems that are used in different parts of the world. In my part of the world, in Nigeria, and a lot of African countries and some Western countries, we use one type of this system, which is kilogram. We always like to measure mass in kilogram. We always like to measure length in meters. We always like to measure time in seconds. It is a system of measurement. Another country may decide that they don't want kilogram because it looks too large. So they want smaller values. So that is why we have different systems of measurement. Number one, I would mention is CGS. So this is one system of measurement. CGS simply measures length. It measures length in centimeter. That is what the C stands for, CGS. It measures mass. It measures mass in grams. That is what the G stands for. And it measures time in seconds. That is the CGS system of unit, right? So some people call it the non-SI unit. So we'll be seeing this. There will be a constant comparison between the CGS and our normal standard measuring unit. So number two is the FPS. So for FPS, it measures length. Measures length in foot, or you can say feet, for that is the plural, foot is the singular. Then it measures mass. It measures mass in pounds. And then it measures time in seconds. So this is the second system of units. Not very, we don't use this often in Nigeria and some African countries and Western. So we'll be talking of this, but the major one is number 3, which is the MKS. The MKS measures length. It measures length in meters. It measures mass in kilogram, and it measures time in seconds. So you see that all of them measure time in seconds, right? Yes. Now, so this is the MKS unit, which is sometimes with some extensions. When you have some extensions to this, you can call the MKS unit, you call it SI unit. So it is sometimes called SI what? Unit. So they say SI unit, it means they want you to measure mass in what? Kilogram. Measure time in what? Second. Measure length in what? Meters. And there are other SI units, right? So that is what it means. Now, the units you saw in my table when I gave examples of fundamental units, the unit I used in that table are what we know as what? SI unit, the standard international unit, right? So these are things you should know. These are the systems of measurement. Now, finally, before I draw this video to an end, we want to now consider abbreviations in units. So we want to look at abbreviations, or we can call them prefixes in units. Now, sometimes we don't like to write large numbers. So you calculated something and then you got 3 million as your answer. We don't like to write 3 million. There are abbreviations for that, or there are prefixes we use so that we don't have to write 3 million, 3 and 6 zeros. We'll now introduce abbreviations, which are very important to us. So let's look at abbreviations. Abbreviations, or you can call them prefixes in units. So this is very important also. Now we're going to learn them. Let me write name. Okay, name. Let's say name. The symbol, and then the prefix. Right? So let's do it this way. So number 1, I would mention, let's start from, okay. So number 1, we want to look at deci. Let's start this way. So number 1 is deci, right? Deca. Let's use deca. Number 1 is deca. Deca is actually symbolized with the symbol DA. Deca. And deca is actually 10 to power 1. Deca, of course, deca comes from 10. So 10 to power 1, which is still 10. So we want to look at number 2, hectare. Hectare is actually HE, which has the symbol 10, the prefix 10 to power 2, right? Now, number 3, we want to look at kilo. Kilo is symbolized as K, which has the prefix 10 to power 3, right? Yes, so what this means, before I continue, if you see something like, let's say 2 kilogram, you have something like this, 2 kilogram. This K is actually this, which you call kilo. So say you want to change this to gram, you don't want it to be in kilo, and you come back to this table and notice that kilo is actually 10 to power 3. So in place of the k there, I would write 10 to power 3. So it means that this would be equivalent to 2. Then in place of k, I will now add times 10 to power 3. Then I would say gram. So it means that 2 kilogram is the same thing as 2 times 10 to power 3 grams, or you can just simply say is equivalent to 2, because 10 to power 3 means 1000. So 1000 times 2 is 2000 gram. So 2 kilogram is equivalent to what? 2000 gram. You can see the importance of what I'm giving you now. So the kilo, number 4, we have 10 to power 6. So we have the mega, which is denoted with capital letter M. Take note of it. We still have small letter m. For this capital letter M, which is 10 to power 6. We have number 5, which is 10 to power 9. That is the giga, capital letter G, 10 to power 9. We have number 6, which is 10 to power 12, which is what? Tera. So capital letter T, 10 to power 12. We have number 7, which is 10 to power 15. 10 to power 15 is Peter. I call it Peter. That is P, capital P, 10 to power 15. We have number 8, which is exa, right? 10 to power 18, right? E, 10 to power 18, EX. 10 to power 18. I just gave the positive prefixes. That is just what I give now. So let me move on to the negative prefixes. So same way, I can say for the negative ones with their symbols also. So I'll go as number 9. Let me do it as number 9. But this time around, I'm mentioning the negative ones. So since I have 10 to power 1, I should have 10 to power minus 1, which is deci. Deci is small letter d, 10 to power minus 1. So it means I should also have 10 to power minus 2. 10 to power minus 2, which is centi. I used to say centimeter. Centimeter. So this is actually C, small letter C. Number 11, I should also have 10 to power minus 3, which is milli. Milli, right? Milli is 10 to power minus 3, which is denoted with small letter m. You can see this one, mega is capital letter M, milli is small letter m. So don't mix them. Try to take your time and go through these symbols. They will help you. Number 12, so it means we should have 10 to power minus 6 also, which is actually what we call micro. Micro, what is the symbol for micro? This is the symbol for micro, mu. The symbol for micro. Number 13, we should have 10 to power minus 9 also, which is called nano. Nano. And what is the symbol for nano? Small letter n. So we should also have 10 to power minus 12. 10 to power minus 12, which is what? Pico. So pico is small letter P. This is capital letter P. And we should have number 15, which should be 10 to power minus 15, right? Yes, 10 to power minus 15 should be femto. Femto, which is small letter F. Then we have number 16, which should be 10 to power minus 18. I think I've tried at this point to be able to give you all this. Can you guess what this one should be? Can you tell me what this should be without me writing it? Drop the answer in the comment if you know what it should be. So 10 to power minus 18 is what? Ato, which is actually, we can drop the symbol for this in the comment section if you know it. So these are the abbreviations that you would always see us use in physics, and that's why this topic is very fundamental to physics. So I'll be dropping in my next video, we'll be getting deeper into this analysis, and then I'll solve one problem here, and then we move into dimensional analysis and begin to tackle more problems. If you have watched this video to this point, do well to subscribe if you are yet to subscribe. Share this video with all your friends that need to learn physics and science. Tell them prime concept is unraveling the concept of sciences. Thanks for watching my videos. Prime concept. I'll see you in my next video.